Today we're going to learn about finding the areas of various shapes. You will be given a formula sheet with most of these formulas on, and it's already in your packet, but you will be given an additional one for the SOL and for the test. So please make sure you're familiar with how to use the formulas. So the first formula we're going to work on is a triangle. So the area of a triangle is 1/2 base times height. We usually write B for base, H for height. The key thing is knowing what B and H mean. So the base is the side of triangle perpendicular to the height. And then the height is the distance from the vertex of a triangle to the base, and the height has to be perpendicular to the base. So in a right triangle, it's pretty easy. The height and the base are both sides of the triangle because they form a right angle with each other. But if it's not a right triangle, our height would be the distance from our vertex to the other side, to our base. So that's our height. It forms a right angle, and our base would then be this. Okay, but the key thing is base does not always mean the bottom. For this one, we don't have anything with a right angle. So to draw the height or the altitude, when we drew altitudes for an obtuse triangle, we always said it's outside the triangle. So the altitude is actually the height of the triangle, and it is outside the triangle because this is the distance from the vertex to the base, and it forms a right angle. So this would be my height. Now my base is still this section here. It has to be a side of the triangle. The base does have to be a side. So the base is this side. It's not this entire length. That's a key distinction. So if we look at this, we want to find the area of these three triangles. We're going to use our formula 1/2 base times height. So our first one, we have a right triangle, and we know that the base is this distance of 60. So we have area is base times height, and we can plug in 60 for our base. Now our height is this side because it measures the distance from the vertex to the base, and it forms a right angle, but we don't know that. So we have to look at our triangle and see what other information they give us to help us find us, and they give us an angle and a side. So we can either use our 30, 60, 90 chart or trigonometry to find the height. I'm going to use trigonometry since we're probably more familiar with it. So if we label our side, 60 is my adjacent to my angle of 30, H is my opposite, and so our trig function that we would use is sine is opposite over hypotenuse. So we can write out SOHCAHTOA to help us remember which trig function, and since we have O and A, we're going to use tangent. So to find the height, we're going to say tangent of the angle, which is 30, is opposite, so that's H over adjacent, which is 60. We remember put this over 1 and cross multiply to solve, so H is 60 tangent of 30. So then you type that in your calculator to get the answer, and the height is 34.6 if we round to the nearest tenth. Make sure your calculator is in degrees. And now we can plug our height into our formula. So we have area is 1/2. Forgot the 1/2 up here, so I'm going to add that 1/2 base times height. And so we're going to do our 34.6 times 60 times 0.5. And our area is 1039.2. And if we put units, it's feet squared. So then we have this triangle. They give us, so if we look at this, height is the distance from the vertex to the base, so our height is 5. And then we need the base. So the base is the entire length. I believe 6 only indicates this side, and so it would be, this would also be 6 since it's perpendicular, and so the whole thing would be 12. And so our area would be 0.1/2 times 12 times 5, which gives us 30. And then for our last one, this is our obtuse triangle. So remember, the height has to form a right angle. So this would be our height here. Outside the triangle is our altitude. Again, they don't give it to us, but we have this triangle here. So we can use Pythagorean theorem, which C is our 5, because that's across from our right angle, and solve. So we're going to get h squared equals to 9 when we solve it. So h is 3. And then our height is 3. Now the key thing is our base. Remember, our base has to be a side of a triangle. So H is perpendicular to this side, but the side of the triangle is only 6. So our area would be 1/2 3 times 6. We don't use 10 because 4 is not on the triangle. And then we can multiply those together and we get the area to be 9 of our last triangle. The second shape we're going to do is a parallelogram. Now a parallelogram formula applies to multiple shapes. It could be a rectangle, a square, a parallelogram, or a rhombus. So we can use base times height for any of those shapes. Now for the height, it's the distance between the two bases, and it must form a 90-degree angle with the base. And a base is one of the sides. So for this, we have a rectangle. This one's pretty easy. We have the base of 4 and the height is 10, so the area is 40. For a square, one thing you have to remember is that a lot of times they're not going to give you more than one side of a square, but all the sides are equal. So the base and the height are the same. So a lot of times for the area of a square, they say it's the same as s squared, and s stands for a side. So that's another way to write the formula for a square. But you can just remember base times height, and that base and height are equal. So this first question on a square says find the expression for the area given that each side is x plus 2. So our base would be x plus 2, and our height would also be x plus 2 because all of our sides are equal. And so our area would be, you could either say x plus 2 times x plus 2 or x plus 2 squared. And that would be the expression for the area. And then our last example in parallelograms on this slide is this one. And so if we look, our height has to be the distance between the two bases. So our height would be here. And again, they don't give it to us, so that means we're going to have to find it. Now our base has to be perpendicular to our height. So it's going to be this side or this one, and they're both 15. So we have to figure out our height. Now if we look at this, we have a right triangle. This 34 represents an angle, and this angle has to also be 34 because opposite angles in a parallelogram are equal. So again, now we have a side and an angle of a triangle, and we can use trig again to find it. So 10 is my hypotenuse. H is my opposite because it's across from the 34, and then O and H is sine, so we would have sine of 34 is equal to H over 10. You put sine of 34 over 1, cross multiply, so it would be 10 sine of 34 is your height. You type that in your calculator, and then we find that the height is 5.6 if we round to the nearest tenth. And so now we do our formula, base times height, because we have everything. So our base is 15, our height is 5.6, so our area is 83.9 for our parallelogram. So for a lot of times for parallelograms, you're going to have to do a little extra work to find a height or a base of it. And this one says, don't let some questions fool you. So we want to make sure we identify what is the base and what is the height. I usually always start with the height because once I know that, whatever it's perpendicular to is the base. So on this one, the height is the distance between the two bases, so it's 12. The base then has to be 20 because that's the side that's perpendicular to 12. So the area would be 20 times 12, which is 240. Our third type of shape is a trapezoid. So for the trapezoid, we have 1/2 h times b1 plus b2. H again is the distance between the two bases. Okay. Again, it has to be perpendicular to the bases. And in this case, because the bases are two different lengths, we add them together to get the area. So B1 is the length of one parallel side and B2 is the length of the other parallel side. These you can change the numbers, it doesn't matter. So on our first picture of our isosceles trapezoid, B1 is the length of this base, B2 is this, and H is here. So on an isosceles trapezoid, we never use the legs in our area formula. In this trapezoid, the right one, we have our base here, and our height is our distance. So remember, base doesn't mean bottom, it means the length of the parallel sides. So for our first trapezoid, we want to find the area of this one. We have all the information, so we do 1/2, our height is 5, our B1 is 10, and our B2 is 6. And you can switch 10 and 6 if you want, and then we make sure you do order of operations. So 10 plus 6, you do parentheses first, which is 16, and then you do 1/2 times 5 times 16, and our area is 40. For this trapezoid, we need the height. So the height again is the distance, and we have a problem, they didn't tell us it. So again, we have a right triangle. So let's see if we can figure out this side. So we know the top of this is 10. We have a rectangle, so this side length is also 10. And if the whole thing is 19 and this is 10, this has to be 9. We would do 19 minus 10, that would give us 9. And then we have two sides of a right triangle. We're trying to find the third, so we do Pythagorean theorem again. So we do a squared plus b squared is equal to c squared. 9 squared is 81. 15 is 225. You subtract them and you get 144, and then don't forget to take the square root, and our height is 12. And so now we're going to do our formula of 1/2, the height, which is 12, and then our bases are 10 and 19. Make sure you use the whole base for both of them. And don't again forget order of operations, or put parentheses in your calculator when you type it in. And if you multiply that out, you get the area to be 174. And then the area of the rhombus, we learned this formula already, but it's not on the formula sheet, so you need to be careful about that. So D1 stands for diagonal 1, D2 is diagonal 2. It doesn't matter which one you call diagonal 1 or diagonal 2, but make sure you do the whole distance. So this you could say is D1, and then this distance you could say is D2. It doesn't matter which one you call, but make sure you do the entire distance. So on our two rhombi, we're trying to find our area. So we need 1/2 D1 times D2. So we look, they gave us half the diagonal because they're cut in half for a rhombus, which is 3. So the other half is 3, and the whole diagonal has to be 6. But we have a problem, they didn't tell me the other side. So remember, diagonals are perpendicular for a rhombus, so that's a right angle. So again, we use Pythagorean theorem. So we do x squared plus 3 squared is equal to 5 squared. If you remember that this is a special right triangle that is always 3, 4, and then 5. So you could just write 4 if you know that. But if you solve this equation, you would get 4. So this is 4. Again, it's cut in half, so this side is 4, and my whole diagonal is 8. And then you multiply it out, and you get 24. This example is the same idea. We have a right triangle, 17, 8. We use Pythagorean theorem to find the missing side. And then we solve it. And so you get x to be 15. And then we need the length of the whole diagonal for both of them. So we have 1/2, 16 because we have 8 and 8, and then 30 because we have 15 and 15. And then we just multiply them together, and we get 240 for the area. So that is a rhombus. If they give you a side and the height of the rhombus, then you can use our formula base times height for a parallelogram. Then a kite. This is another one that's not on the formula sheet. But if we look at just half the kite, it makes a triangle. And so for a triangle, we can use 1/2 base times height. So the area of the triangle in this case would be 1/2. The height would be your right angle, so it would be 4, and your base is what the side that's perpendicular, so that's 10. So our area of a triangle would end up being 20. Now to find the kite, we would just take that area and we would multiply it by 2, which is 40. So we can use that idea to help us find it. So in this one, we have 2 triangles in our kite. So this is 1 if we just focus on it. So we could do area is 1/2 base times height. Now with this triangle, we have a problem. This is my height because it's the distance from the base to the vertex, and we don't know it. But we again have a right triangle, so we can use Pythagorean theorem, with 15 being our C, to find the height. So we square them again. And you solve, and you get h is 9 when you solve it. So this length is 9. So now we know our height, which is 9. Now the base is the entire side. So again, we don't know the base, but this is also 9 because the short diagonal is cut in half. And we can use, if we call this x, Pythagorean theorem again. So we do x squared plus 9 squared is equal to 41 squared. And that gives us x to be 40 when we solve it. And so our base is the whole length. So we have 40, but we have to add 12 to it to get 52 as the whole base. And so we have 52 times 9 times 1/2, which is 234. Now this is the area of the triangle. So then the kite, we do 2 times 234, which is 468. Now if we want a formula for this, we can look at what we did. So we would do 2, what we've been doing for the kite is we're taking, so if you want to memorize this instead of doing that, you can. So we said area kite was 2 times 1/2 base times height. And in this case, 2 times 1/2, the base was the length of the long diagonal, and the height was the half the short diagonal. And so if we simplify this, the area is actually just the long diagonal times half the short diagonal. Because the 2 times 1/2 is just 1. So that's our formula. You don't ever have to memorize that if you just remember that a kite is a triangle, and you can find the base and height of the triangle and then multiply by 2. Then the last thing we're going to do is area of complex shapes, which means it's going to be 2 shapes together or just a shaded region or part of a shape. So if we look at our first one, what 2 shapes we have? We have half a circle, and we have a triangle. So we're going to find the 2 areas and add them together. If we have 2 parts, we take the area of both and add them together. So a circle is pi r squared. The radius would be from the center to the end, so it's half the diameter, so it'd be 4. So we have pi 4 squared, which is 16 pi if I leave it in terms of pi. A triangle would be 1/2 base times height. Now they don't give us the height, so we have to draw it in. So that is our height. Again, we don't have it, but we have a right triangle because we know the height makes a right angle. This has to be half of it, so that's 4. So we do h squared plus 4 squared is equal to 5 squared. Again, h is going to be 3. If you solve it, that's one of our popular ones, 3, 4, 5 triangle. So we would have 1/2. The entire base is 8. The height is 3, so it's 12. So the area of the entire figure is we add them together. So we have 16 pi plus 12. Now, if it's in terms of pi, if they ask you, you leave it like that. You can't add them because they're not like terms. If you want to add them, you have to get 16 pi as a decimal, which is 50.3. And then I add 12, which is 62.3. So that would be the area of our complex shapes. Then we have, it's like a tire. So we're trying to find the area of just the outside. Now, if we look at this, the outside is not a formula we know, but we have a circle, the whole thing is a circle, and then we have this middle circle. So to find the area of the shaded region, we take the area of the entire thing and we subtract the area of the unshaded part. So that's how we find the area of the shaded region. So they said, what two shapes are there? We have two circles. So we're going to find the area of the whole circle. So that's pi r squared. Now our radius for the whole circle, if we look at this, would be this whole distance. So this is 6, that's my radius, and then we have 2, so that's 8, and so we have 64 pi. Then we can do the area of the inside circle. If we scroll back to our picture, that radius is 6, so we have pi 6 squared, which is 36 pi, and then the area of shaded is we just subtract them. So we would do 64 pi minus 36 pi, which in terms of pi is 28 pi. If you don't want it in terms of pi, then you multiply 28 by pi, and you'd get 88 if you round to the nearest 10. So for more examples of this, they said find the area of the shaded region. So if we look at this, we want to do the area of the entire thing minus the area of the pieces, or for this one we could just find the area of the 4 pieces and add them together. So the problem is for this we have 30 is the length, and then we have 15, so the area of the entire is 30 times 15, which is 450. And then we're going to do the non-shaded region, each piece. So the length, this is 15 for all of them. This height is 5, so we have 15 times 5. So this area is 75. For this one, 15 again is the length. The height of this one is 7, so we have 105. 5 is our height, 15 again is our base. So for this one, we have 75 again. So I'm finding the area of all our pieces, and then we would subtract our total area, which is 450. So this is for area of our shaded. And we would subtract 75, and then 50, and then 75 again. Sorry, not 50, 105. And so our area is 195 for this. This one says find the area of the shaded region. The two circles are congruent, so that means they both have a radius of 5. So again, shaded region, we take the area of the entire thing and we subtract the area of the non-shaded. So the area of the entire is a rectangle, that's the shape. So we learned that a rectangle is base times height. Now we need the base and height. So we have a circle all the way across, it would be 5 radii. So the base would be 5, 10, 15, 20, or 5 times 4, which is 20. The height, well, this is a radius again, so that's 5. This distance is a radius, so that's 5, so the height is 10. So we have 20 times 10, so our area of our rectangle is 200. Then we have our circles, so the area of those is pi r squared. So we have pi 5 squared, which is 25 pi, but we have 2 circles. So the total area is 2 times 25 pi, which is 50 pi, which is 157.1. And then to find the area of the shaded, you would do the area of the rectangle, which is 200, minus the area of the 2 circles, which is 157.1. So I'd do 200 minus that, and we get 42.9 for the shaded area. Okay, and then these are our last two problems. So we have the area of a shaded region for both of these. We want to find it. So if we look at this, we have a composite figure. We have a rectangle and a triangle, but then we took this square out. They're going to say this is a square. Okay. So when we do this, for the first part, our rectangle, we would take the area of the entire rectangle, which would be 8 times 12, which is 96. The area of the square would be 5 times 5, which is 25. And so our area would be 96 minus 25 for the part of the shape. So that's 71. And then we need to add the triangle, which is going to be 1/2 base times height. So we have to figure out what is our height. So our height would cut this in half. So that's 4. We need our height. Again, we use Pythagorean theorem. This is our one we've been doing multiple times, so it's 3 again. And so we have 1/2. Our height is 3. Our base is 8 because it's the length the whole way. So our area of a triangle is 12, and then we add it to the area. So the total area, we add it to the area of the shaded part of the rectangle, which we found is 71. We add the triangle, which is 12, and we get 83 as our total area. And then for this one, so we have a fourth of the circle or a sector. So to find the area, we can use our sector formula or fourth. So we said our sector formula is 90 over 360, angle over 360 times pi r squared, so 8 squared. So this is our sector, our part of our circle. You could always do 1/4 right away if you just noticed that. So we get 16 pi, which I'm going to put this as a decimal because we're going to have to subtract another region, so that's 50.3. Then we're going to take away this piece from it, which is a triangle. So we need the area of the triangle, which is 1/2 base times height. So that's 8 times 8. This is 8 because it's a radius as well. So that's 32. And then our shaded region, we just subtract them again. So then we have 32, or sorry, we take the bigger number first. So we have 50.3 minus 32. And so our area is 18.3. And that's it for the area. So you can try some of 11B to practice what we just did, and we'll be practicing them in class tomorrow.